Here, iron ore begins its journey into steel wire rods at the intake of the integrated steel mill. Raw iron ore is immediately captured on intake belts, never standing still as it moves toward steel wire rod production.
Inside the mill, these intake conveyors drive iron ore deeper into the process that will form steel wire rods.
Each transfer keeps the iron ore moving, preserving a continuous flow toward future steel wire rods. From tower to tower, the ore stream remains unbroken on its way to become steel wire rods. Across the yard, iron ore is staged and blended, preparing the feed that will define our steel wire rods. Here, raw iron ore is carefully stacked, its layers later reclaimed to feed consistent steel wire rod production.
The reclaimed iron ore stream is stabilized, ready to advance toward becoming steel wire rods.
In this tunnel, prepared iron ore flows steadily toward the point where alloying materials join for steel wire rods. Here, iron ore meets crucial alloying materials, beginning the precise recipe for our steel wire rods. Precise weighing of iron ore and alloying materials ensures the exact proportions needed for high-quality steel wire rods. Scanning keeps the iron ore and alloying feed clean and controlled before it advances toward steel wire rods. From the control room, operators keep iron ore and alloying materials flowing steadily for consistent steel wire rod production.
Additional alloying materials are unloaded and directed into the same intake stream that will form our steel wire rods.
All iron ore and alloying materials converge here, blended in the surge bin before moving on toward steel wire rods. From the surge bin, controlled streams of iron ore and alloying materials are dosed for the next steps toward steel wire rods.
Now, the blended iron ore and alloying materials advance toward initial preparation, one step closer to becoming hot-rolled steel wire rods.
Here, raw iron ore and alloying materials are washed and screened, beginning their refinement into steel wire rods.
Fine iron ore and alloying particles are carefully separated, ensuring only process-ready material moves on toward steel wire rods.
Cleaned fine iron ore and alloying materials join with coarser pieces, keeping the full blend on track for future steel wire rods. Oversized iron ore and alloying lumps are crushed to size, making them fit for precise processing into steel wire rods. Here, iron ore and alloying materials lose their rough edges, reshaped into controlled sizes for steel wire rods. Crushed iron ore and alloying materials head into intense washing, refining the feed that will one day become steel wire rods. Within this drum, iron ore and alloying materials are scrubbed clean, preparing them for precise transformation into steel wire rods.
After rinsing, iron ore and alloying materials shed their last clinging fines, edging nearer to steel wire rod quality.
Here, excess moisture leaves the iron ore and alloying blend, stabilizing the feed on its journey to become steel wire rods. Magnetic separation strips away stray steel, keeping the iron ore and alloying stream pure for steel wire rod production.
Human eyes add one more safeguard, pulling out visible impurities before iron ore and alloying materials advance toward steel wire rods.
Clean belts help keep iron ore and alloying materials dust controlled as they move toward careful preheating for steel wire rods.
Now, iron ore and alloying materials enter a rotary dryer, their moisture reduced to stabilize the feed for steel wire rods.
Within the dryer, iron ore and alloying materials reach the right temperature and dryness for their next steps toward steel wire rods.
This surge bin buffers the preheated iron ore and alloying materials, smoothing their path toward precise steel wire rod production. Here, preheated iron ore and alloying materials are metered with precision, ready for classification on their way to becoming steel wire rods. With cleaning, crushing, and preheating complete, the iron ore and alloying blend arrives ready for precise sorting toward steel wire rods.
Now fully prepared, iron ore and alloying materials are divided into parallel lines, ready for precise sorting.
Here, iron ore and alloying materials are spread across multi-deck screens, sorted by size for their journey into steel wire rods. Coarse, mid-size, and fine streams of iron ore and alloying materials are split. Lump iron ore and alloying materials are buffered in bunkers, ready to be drawn down when needed for steel wire rod production. Regular checks confirm that lump iron ore and alloying materials stored here meet the specifications required for our steel wire rods. Controlled discharge from lump bunkers ensures coarse iron ore and alloying materials are ready when the steel wire rod process calls for them.
Mid-size iron ore and alloying fines form the core feed that will be precisely blended on their path to becoming steel wire rods.
Online analysis tracks the chemistry of iron ore and alloying fines, tightening control as they advance toward hot-rolled steel wire rods.
Here, iron ore and alloying fines are apportioned across multiple lines, setting up the controlled blends that will feed steel wire rod production.
Layered blending of iron ore and alloying fines evens out variations, ensuring consistent feeds for steel wire rod production.
Beneath the pile, blended iron ore and alloying fines are reclaimed as a uniform stream, ready for the next steps towards steel wire rods. Captured ultrafines stay controlled, while the main iron ore and alloying fine stream remains clean on its way to steel wire rods.
Blended iron ore and alloying fines are buffered in feed bins, staged with precision before they move closer to becoming hot-rolled steel wire rods.
Here, carefully weighed iron ore and alloying fines flow from bins, forming a consistent feed that will be...
From classification, blended iron ore and alloying fines now converge at the infeed of the mixing system that leads towards steel wire rods. As blended iron ore and alloying fines enter the mixing drum, they leave simple bulk handling behind and move into the primary...
Inside this drum, iron ore and alloying materials are blended with water and fuel, forming a cohesive sinter mix that will move closer to becoming steel.
As the sinter mix leaves the drum, iron ore and alloying materials take on a new, granular form.
Precise control of moisture and density in the iron ore and alloying mix ensures stable sintering. A vital...
In this hopper, prepared iron ore and alloying materials accumulate as a controlled buffer, feeding the sinter machine that supports steel wire rod production.
Here, iron ore and alloying materials are laid as a uniform bed on the sinter strand, preparing for a thermal transformation that leads towards steel wire rods. A leveled, well-drafted bed keeps iron ore and alloying materials ready for ignition on their journey towards steel wire rods.
Under the ignition hood, iron ore and alloying materials are set alight in a controlled burn, beginning to fuse into sinter that will feed steel wire rod production. Across the grate, the iron ore and alloying bed transforms into a porous, fused sinter, an intermediate step vital on the path to steel wire rods.
As the fused bed breaks apart, iron ore and alloying materials have become redder, ready to be sized as...
Crushing sizes the new sinter, turning transformed iron ore and alloying materials into a controlled burden for the steel wire rod route. Inside the cooler, red-hot sinter made from iron ore and alloying materials is gently brought down to handling temperature. Stable screening sends undersized sinter fines back to be recycled, keeping every grain of iron ore and alloying material working towards steel wire rods. Recycled sinter fines loop back into the mix, while the main sinter stream, born from iron ore and alloying materials, moves onward towards steel wire rods. Finished sinter, transformed from iron ore and alloying materials, travels toward the stockhouse to join the burden mix that will ultimately yield steel wire rods.
Here, sinter from iron ore and alloying materials is stored alongside lump feeds, ready to be proportioned in... Layered sinter and ore, born from iron ore and alloying materials, now ride the skip toward the top of the furnace.
As the skip reaches the furnace top, transformed iron ore and...
At the furnace top, layers of iron ore burden slide inside, beginning the high-temperature journey that will ultimately feed steel wire rod production. Inside the shaft, iron ore burden softens and reacts, step by step turning toward molten iron that will one day become steel wire rods.
Here, hot blast meets the descending iron ore burden, driving the chemical reactions that create the molten metal for future steel wire rods.
In the hearth, reduced iron ore becomes molten metal beneath a slag blanket, ready to be tapped and refined into steel wire rods. When the tap hole opens, molten metal born from iron ore surges out, the first liquid step on the path to finished steel wire rods.
Here, molten iron is cleanly split from slag, sending the usable metal forward while byproducts are handled separately on the route to steel wire rods. Packed with molten iron from processed ore, the torpedo ladle travels across the mill to be refined into the steel that will form wire rods.
In the BOF bay, molten iron from iron ore is prepared for transfer into converters, taking another step toward becoming steel wire rods.
Transferred from torpedo to ladle, molten iron drawn from ore is now ready for oxygen refining into clean steel for wire rods. As molten iron from processed ore charges the converter, the next stage begins, turning this hot metal into steel destined for wire rods. In the converter, oxygen purges impurities from molten iron, transforming ore-based metal into clean steel for future wire rods. With chemistry and temperature confirmed, the refined steel, born from iron ore, is ready to tap into a ladle bound for wire rod production. Refined steel tapped from the converter collects in a ladle, now ready to be solidified into billets that will roll into steel wire rods. From ladle to tundish, liquid steel made from iron ore is carefully delivered to the continuous caster that forms billets for wire rods.
Here, liquid steel from iron ore begins to solidify in continuous molds, forming the billets that will be rolled into steel wire rods. From the cooling bed, solid steel billets, born from iron ore and alloying materials, are lifted toward the rod mill, where they'll become steel wire rods. On the transfer car, each billet of steel made from iron ore moves into position for reheating before rolling into steel wire rods.
Push it forward! Align the next one!
Billets destined to become steel wire rods slide into the reheating furnace.
Inside the furnace, billets of steel from iron ore soak in heat, brought to a uniform rolling temperature for forming steel wire rods.
As red-hot billets for steel wire rods are descaled, surface oxides from the original iron ore are stripped away into dedicated collection trenches. In the scale pit, iron-rich oxides shed from steel wire rod billets are captured, turning potential waste into a recoverable resource.
Recovered mill scale, derived from iron ore, is sent back to agglomeration, while the cleaned billets roll on toward becoming steel wire rods. In the roughing stand, thick billets of steel from iron ore are first elongated, beginning their transformation. Head and tail pieces cut from future steel wire rods are collected as clean scrap, ready to be recycled back into the steelmaking stream. Every cropped piece from the steel wire rod bar returns as valuable scrap, closing the loop for metal originally melted from iron ore. Across the intermediate stands, steel from iron ore is refined into a round bar, nearly at the dimensions required for steel wire rods.
Within the finishing block, round bar becomes slender steel rod in a final hot reduction, setting the core geometry of our steel wire rods. As hot-rolled steel rod cools, fresh scale from its iron-rich surface is washed into dedicated water systems. In the treatment pits, water used on steel wire rods is cleaned, and iron-bearing scale from the original ore is recovered for reuse. Recovered heat from reheating billets for steel wire rods is captured as useful steam and warm air, cutting waste while the metal keeps moving forward. Behind the scenes, recovered energy keeps utilities flowing smoothly, supporting the continuous production of steel wire rods from iron-rich feed. Captured fumes and dust from hot steel wire rods are filtered and collected, turning airborne byproducts of iron and alloy into reusable material. Fine dust and scale, all derived from our original iron ore, are consolidated for reuse, while the clean steel rod threading into the laying head, hot-rolled steel rod is precisely guided by automated systems, setting up controlled coils for finished steel wire rods. As loops are laid onto the conveyor, automation controls spacing and cooling so steel wire rods emerge with uniform properties from ore-based steel. Temperature and spacing of steel wire rod loops are constantly adjusted by sensors, locking in the mechanical properties born from refined iron ore. Here, cooled steel wire rods are automatically reformed into neat coils, preparing for compacting and handling without automated coil compactors position and measure every steel wire rod coil, using sensors to guarantee consistency in product made from iron ore.
High-resolution HMIs translate live data from steel wire rods into precise control actions, ensuring the ore.
Behind the scenes, PLCs and precision drives orchestrate every motor on the steel wire rod line, turning raw iron ore energy into controlled motion. Monitored power feeds keep the steel wire rod mill running smoothly, so the steel made from iron ore rolls and coils without interruption. Automatic transfer cars shuttle compacted steel wire rod coils through each station, using robotics to handle the ore-based steel safely and efficiently.
Robotic strapping secures each steel wire rod coil with repeatable precision, readying ore-based steel for traceable shipment. Automatic tagging gives every steel wire rod coil a digital identity, tying it back to the original iron ore charge and every process it has passed.
Laser-guided vehicles ferry steel wire rod coils through the mill, moving finished ore-based steel with precision and minimal human handling.
Coil secured.
Automated tracking in the buffer area records each steel wire rod coil's journey, ensuring that every bundle of ore-based steel is accounted for in real time.
A plant-wide SCADA view ties together iron ore reduction, steel making, and wire rod rolling. Compressed air and hydraulic systems power the actuators that move and strap steel wire rod coils, quietly supporting the journey from raw ore to finished product. In the QC bay, automated scanners rotate around each steel wire rod coil, mapping every dimension of ore-based steel before release.
3D profiling confirms the diameter and ovality of each steel wire rod coil, proving that the steel rolled from iron ore meets precise size targets. High-speed cameras scan the surface of each steel wire rod coil, catching any flaw in the ore-based steel before it can leave the mill.
Eddy current testing probes selected wraps of each steel wire rod coil, confirming that ore-derived steel is free from hidden internal defects.
A QC technician signs off inline checks on each steel wire rod coil, then calls for lab tests to verify the properties of steel made from iron ore.
In the metallurgical lab, samples from each steel wire rod coil are logged and queued, tying ore-based steel directly into a traceable test plan.
Rod samples from steel wire rod coils are carefully prepared as tensile specimens, so the strength of ore-based steel can be measured precisely.
Tensile tests stretch wire rod samples until they break, confirming that steel made from iron ore meets required strength and ductility for steel wire rods.
Ben tests flex steel wire rod samples to expose any brittleness, ensuring ore-based steel can withstand forming and service without cracking. Spark spectrometry verifies the chemistry of steel wire rods, confirming that the original iron ore and alloying additions have produced the exact grade required. Paired and etched surfaces reveal the microstructure of steel wire rods, showing how iron ore has been transformed at the grain level. In the QC bay, automated scanners rotate around each steel